All right, we'll look at some of the homework problems that are in section 7.1 that deals with rational numbers and decimals. In this case here, we want to write the following sum using powers of 10 to show place value. In this case, we got 0.597 or 597 thousandths as appropriately read. Now we have to look at each place value position when we write this in expanded notation. The 5 is the first number behind the decimal point. That's the tens place. So we're going to represent that as 5 times 10 to the negative 1. Then plus, the 9 is in the hundreds place. So that's going to be 9 times 10 to the negative 2. And then the 7 is in the thousands place. So that's 7 times 10 to the negative 3. Okay, that's how you're going to be writing the sum of a decimal value in expanded notation. Because the tens place is 10 to the negative 1, the hundreds place is 10 to the negative 2, and the thousands place is 10 to the negative 3. All right, problem number 2 is to write each decimal in numbers, like 560 and 5 thousandths. Well, the number 560, we can write that as 560, and the word "and" represents your decimal point. Now, the word 5 thousandths, we need to write 5 thousandths with 3 numbers behind the decimal point. The 5 will take the last decimal place because it is in the thousands place. Because that's tenths, that's hundreds, and that's thousandths. The other numbers, the other spaces would need to be filled with zeros. So now, 560 and 5 thousandths written in decimal notation will be 560.005. All right, number 3 is to write 0.0028 in words. Now here they're going to give you a choice from the drop-down menu to choose from. But in this case, we would read this number as the number 28. So we write 28 in word form. And 28 will have the name of the place value position that the last digit is in. Here the 8 is the last digit. It is in the 10 thousandths place. Here we got the decimal point, that's your tenths, hundreds, thousandths, 10 thousandths. So here we're going to give 28 the name 10 thousandths. And make sure you put THS there. Okay, problem number 4. Looks like this. Without performing the actual division, determine whether the following represents a terminating decimal. Here we got 23 over 2 to the second times 25. And we want to know, does that represent a terminating decimal? Okay, I'm going to rewrite 25 as 5 to the second, because I know 5 times 5 gives me 25. All right, there was a rule that we talked about on the Wimber presentation that deals with terminating decimals. Here, a terminating decimal cannot have no prime numbers other than 2 and 5 in the denominator. Here we only have the 2 and the 5 in the denominator. We have no other prime numbers in the denominator. So in this case, yes, this particular rational number would represent a terminating decimal. All right, number 5, write 1/8 as a decimal. Okay, the way you can do this is through long division. We can divide the denominator into the numerator. Here we can divide 8 into 1. And here we're going to place the decimal point behind the 1, and we'll place a decimal point in the quotient. And since we can't divide 8 into 1, we'll put a 0 there. but we can divide 8 into 10. That's going to go one time. So 1 times 8 will be 8. 8 from 10 will be 2. Now what we need to do is add another 0, bring it down. Divide 8 into 20. That's going to go 2 times. That'll be 16. 16 from 20 will give you 4. Add another 0 and bring that down. And then 8 goes into 20 5 times. Here we'll have a 0 remainder. So 0.125 will be the decimal for 1/8. So 1/8 as a decimal will be 0.125. All right, problem number 6 is to arrange in order from smallest to largest. We got 0.8268, 0.076, and 0.6946. What we can do here is place those numbers or line up those decimal place value positions so that each number, we can compare each place value position one at a time. And what I'm going to do here is put 2 zeros here. That way I'll have the same number of decimal places for all my numbers. Now I'm going to compare each place value position one at a time to see which one is bigger. Now we're doing from smallest to largest. Now notice the 10th place. They're different right off the top. So as you can see here, the smallest will have to be the 6, which means 0.6946 will be first. And then next will be 0.76, that's second. And third will be 0.8268. So from smallest to largest, you'll have 0.6946 going first, and then 0.76 going second, and then finally 0.8268 last. So that's how you'll place those numbers from smallest to largest. And finally, number 7, the 5 top swimmers in an event had the following times. And here's the table here that we'll be looking at for the 5 swimmers. And in this case here, we want to put in order how they were placed. Okay, so here, in this case, we want to look at each of those numbers from smallest to largest in this case here. Well, see that the 6's are the same. Now here, in the units place, they're different. So here we got 0 here and a 0 here for Kathy and Martha. But we want to know which one finished in the shortest time. And as you can see here, Kathy finished in the shortest time because Kathy finished at 60.02 seconds, where Martha only finished in 60.42 seconds. So in this case here, Kathy will be first, and then Martha will be second. Now for Emily and Rhonda, as you can see here, Emily finished quicker than Rhonda, 61.03, then 61.47. So Emily finished third, and Rhonda finished fourth. That means that Molly finished last because she had the greatest time or the slowest time. Okay, so in this case here, the correct answer would be Kathy first, then Martha, then Emily, Rhonda, and Molly. Okay, so this should be enough to assist you with some of the homework problems that are on the MyMathLab system for Section 7.1.